Good day, everyone. My name is Myrivie Meyor, BSS 3B. I'm going to report about techniques on uncertainty, reasoning, uncertainty factors. Introduction. What is uncertainty? Information can be incomplete, inconsistent, uncertain, or all three. In other words, information is often unsuitable for solving a problem. Uncertainty is defined as the lack of the exact knowledge that would enable us to reach a perfectly reliable conclusion. Classical logic permits only exact reasoning. It assumes that perfect knowledge always exists and the law of the excluded middle can always be applied. If A is true, then A is not false. If A is false, then A is not true. Source of uncertain knowledge. Weak implication. Domain expert and knowledge engineers have painful task of establishing concrete correlation between if, condition, and then action is parts of the rules. Therefore, expert systems need to have the ability to handle vague associations. Example, by accepting the degree of correlation as numerical certainty factors. Imprecise language. Our natural language is ambiguous and imprecise. We describe facts with such terms as often and sometimes, frequently and hardly ever. As a result, it can be difficult to express knowledge in the precise if-then form of production rules. However, if the meaning of the facts is qualified, it can be used in expert systems. In 1944, Ray Simpson asked 355 high school and college students to place 20 terms like often on a scale between 1 and 100. In 1968, Milton Haeckel repeated this experiment. Unknown data. When the data is incomplete or missing, the only solution is to accept the value unknown and proceed to an approximate reasoning with this value. Combining the views of different experts. Large expert systems usually combine the knowledge and expertise of a number of experts. Unfortunately, experts often have contradiction opinions and produce conflicting rules. To resolve the conflict, the knowledge engineer has to attach a weight to each expert and then calculate the composite conclusion, but no systematic method exists to obtain these weights. Basic probability theory. The concept of probability has a long history that goes back thousands of years when the words like probably, likely, maybe, perhaps, and possibly were introduced into spoken languages. However, the mathematical theory of probability was formulated only in the 17th century. The probability of an event is the proportion of cases in which the event occurs. Probability can always be defined as a scientific measure of chance. Probability can be expressed mathematically as a numerical index with a range between 0 and absolute impossibility to unity and absolute certainty. Most events have a probability index strictly between 0 and 1, which means that each event has at least two possible outcomes: favorable outcomes or success, and unfavorable outcomes or failure.
Report is muling continuation sa report ni Mayor. P success is equal to the number of success over the number of possible outcomes. P failure equals the number of failures over the number of possible outcomes. S is the number of times success can occur and F is the number of times failure can occur. Then P success equals PS over S plus F. P success equals Q F over S plus F and P plus Q equals 1 muna siya ang formula sa probability of theory. So, if we throw a coin, the probability of getting a head will be equal to the probability of getting a tail. In a single throw, S equals F equals 1, and therefore the probability of getting a head or a tail is 0.5. Conditional probability. Let A be an event in the word and B be another event. Suppose that events A and B are not mutually exclusive, but occur conditionally on the occurrence of the other. The probability that event A will occur if event B occurs is called the conditional probability. Conditional probability is denoted mathematically as P open parenthesis A times B close parenthesis, in which the vertical bar represents given and the complete probability expression is interpreted as conditional probability of event A occurring given that event B has occurred. So, kani nga formula mo na yung gamiton para sa conditional probability. So, the number of times A and B can occur or the probability that both A and B will occur is called the joint probability of A and B. It is presented mathematically as P open parenthesis ACB close parenthesis. The number of ways B can occur is the probability of B in those, so muna siya ang gamiton para ani. And similarly, the conditional probability of event B occurring given that event A has occurred equals, so kung ma-occurred ko nga equals ang event A o B, so muna siya ang gamiton nga formula. So after substituting the last equation into the equation, kaninasad nga formula ang gamiton. So, certainty factors theory and eventual reasoning. Certainty factors theory is a popular alternative to Bayesian reasoning. A certainty factor or CF, a number to measure the expert's belief. The maximum value of the certainty factor is, say, plus 1.0 definitely true, and the minimum 1.0 definitely false. For example, if the expert states that some evidence is almost certainly true, a safe value of 0.8 would be assigned to this evidence. In expert system with certainty factors, the knowledge base consists of a set of rules that have the following syntax. So, muna ang mga following syntax gamiton. If evidence, then hypothesis or CF, where CF represents belief in hypothesis H given that evidence E has occurred.
Good day everyone. I will continue to discuss the certainty factors theory and evidential reasoning. So, this is the table of uncertain terms and their interpretation in MYCIN. Term certainty factors. Example, consider a simple rule. If A is X, then B is Y. An expert may not be absolutely certain that this rule holds. Also, suppose it has been observed that in some cases, even when the F part of the rule is satisfied and object A takes on value X, object B can acquire some different value Z. If A is X, then B is Y, CF 0.7. B is Z, CF 0.2. Then certainty factor assigned by a rule is propagated through the reasoning chain. This involves establishing the net certainty of the rule consequent when the evidence in the rule antecedent is uncertain. CF HA equals CF AAX CF HA. For example, if sky is clear, then the forecast is sunny, CF 0.8. And then current certainty factor of sky is clear is 0.5. Then CF HA equals 0.5 minus 0.8 equals 0.3. This result can be interpreted as it may be sunny. Common sense suggests that if we have two pieces of evidence, ESX and BSY from different sources, Rule 1 and Rule 2, supporting the same hypothesis C as Z. Then, the confidence in this hypothesis should increase and become stronger than if only one piece of evidence had been obtained. The certainty factors theory provides a practical alternative to Bayesian reasoning. The heuristic manner of combining certainty factors is different from the manner in which they would be combined if they were probabilities. The certainty theory is not mathematically pure, but does mimic the thinking process of a human expert. Comparison of Bayesian reasoning and certainty factors. Probability theory is the oldest and best established technique to deal with inexact knowledge and random data. It works well in such areas as forecasting and planning, where statistical data is usually available and accurate probability statements can be made. However, in many areas of possible application of expert system, reliable statistical information is not available, or we cannot assume the conditional independence of evidence. As a result, many researchers have found the Bayesian method unsuitable for their work. This dissatisfaction motivated the development of the certainty factors theory. Although the certainty factors approach lacks the mathematical correctness of the probability theory, it outperforms subjective Bayesian reasoning in such areas as diagnostics. Certainty factors are used in cases where the probabilities are not known or are too difficult or expensive to obtain. The evidential reasoning mechanism can manage incrementally acquired evidence. The conjunction and disjunction of hypotheses as well as evidences with different degrees of belief. The certainty factors approach also provides better explanations of the control flow through a role-based expert system. The Bayesian method is likely to be the most appropriate if reliable statistical data exists. The knowledge engineer is able to lead and the expert is available for serious decision analytical conversations. In the absence of any of the specified conditions, the Bayesian approach might be too arbitrary and even biased to produce meaningful results. The Bayesian belief propagation is of exponential complexity and thus is impractical for large knowledge bases. That's all. Thank you.